And today's seminar is titled Introduction to Statistics and Reliability and Validity of the Data. Okay, today's presenter is Dr. Evangelos Tsoukatos, who teaches management at the Hellenic Mediterranean University in Greece and is adjunct faculty at the University of Nicosia and UNICAF and the Hellenic Open University. He earned his bachelor's in mathematics from the Aristotelian University of Thessaloniki, Greece, a postgraduate diploma and MA in operational research from Lancaster University Management School, UK, where he also earned his PhD in management. Prior to joining academia, he had extensive experience as consultant and in senior management positions. His research interests are in service management, quality management, cross-cultural management, and entrepreneurship. Dr. Tsoukatos has been involved over the years in various national and international research and educational projects. He holds the position of Vice President, Operations and Development at the Euromed Research Business Institute. He is Associate Editor of Euromed Journal of Business and editorial board member in a number of international scholarly journals. And I would like to invite Dr. Tsoukatos to start with his seminar for today. Dr. Tsoukatos, the floor is yours.
Thanks very much. Welcome, everybody. I can see quite a number of people attending us, some of which I've talked with in the past, being students in several of the courses. Okay. So we'll have a rather relaxed exchange of arguments about the validity and the reliability of scales. Okay, we have actually learned quite a lot from psychometrics on how we can construct and use specific scales to measure several concepts. Concepts that cannot be otherwise measured. I guess everyone has heard the term Likert scales. Likert was an American social psychologist, Francis Likert, who first introduced the scales that we will discuss about today. These were used for measuring otherwise unmeasurable concepts, like, for example, attitudes, behaviors, psychological situations. Later on, when management also adopted the specific sort of methodology, concepts like culture, service quality, beauty, and so on. Okay. So we have a very powerful instrument in our hands that can be used so that we can measure constructs and concepts that are not measurable in the first place. Let's see how we can do that. We also have a very powerful software called SPSS, IBM SPSS, that we will use for today's discussion. You can all have a free subscription to SPSS through the IBM SPSS site. You can have the so-called free student edition that you can use for free of charge. Okay, let's see what these scales are. Let's get some examples here. We have this is, I'm not sure if you can, just give me a moment, please. New share, this. Can you see it? This is a questionnaire that was used for my own PhD thesis that was about service quality in insurance and the effects of service quality on customer satisfaction. And we had only, I had only chosen to introduce the concept of culture on how people understand or perceive service quality and how these perceptions of theirs affect their understanding of customer satisfaction. And this is the actual questionnaire that was used at that time to collect data. As you can see, we have first we have the demographic data, like gender, male, education, family status, income, and so on and so forth. Okay, and then we have a scale actually measuring culture, individual culture. The prevailing scale for measuring culture is the one presented by Hofstede. I will send it to you now. Hofstede. It is a scale that actually models culture in several dimensions, 6 dimensions altogether, and is widely used in the literature to actually identify people's attitudes, beliefs, and behaviors on the grounds of their own or national culture. We have several levels of culture: the personal culture, the national culture, the organizational culture, each of which is the average of the cultures of individuals comprising the specific group. So the first part of the questionnaire is a scale measuring culture. As you can see, there are 20 items in the scale. And then we go on to use the SERVQUAL scale. I will write this as you. SERVQUAL scale.
Dr. Tsoukatos, if you could enlarge the scale of your Word document so we could see it better. Thank you.
Can I do that? I don't know.
Yes, in the corner, down, right in the corner of the Word document.
Okay. Yeah. All right, I will do that. Just give me a moment. Better now?
Yes, thank you. And you can close the other panel on the left. On the left, the panel could be closed. And
so you can see this is a SERVQUAL scale. The SERVQUAL scale was proposed in 1985 from Parasuraman, Zaitham, and Berry. And is a scale that is actually divided into two elements. The first element is the expectations from a service, and the second element is the perceptions of performance of the service. Okay, so quality comes when we can calculate quality as expectations, perceptions minus expectations, all right? And what we need to see is that perceptions are higher than expectations, and so we have a positive quality in each item, as you can see. But what I would actually like to discuss here is how a Likert scale is composed. As you can see, for each item, we have on the right side seven points. This is actually the implementation of the Likert scale, a 7 point or 5 points scale lately. Currently we are mostly using the 5-point scale. We don't use 2 or 4 or 6 points in our scale, because if we do that, we will have a so-called forced distribution, because if you have 6 points, then which one would be the middle point? Would be 3 or 4? We won't have 3.5, okay? So we always need, yes, Clement, just a moment, please. Just a moment, Clement, okay?
Yes, no problem. I'm promoting Dr. Clement as a panelist.
All right. So we have, as you can see, we have an even number of points, 5 or 7, so that we avoid forced distribution, because as you can see here, 4 is a middle point, okay? Or if we have 5 points altogether, 3 will be the middle point. Also, we do not label, but the first, the lowest, and the highest point, okay? The labels that were used are not at all important and extremely important, or that's left in Greek, sorry. Completely agree for high level, and completely disagree for the lowest level, okay? And here are the instructions. We would now wish to examine your expectations of insurance services of utmost quality, okay? Indicate to what extent it must possess each of the characteristics E1 to E26 that follow. If you think that the characteristic is not important at all for an excellent insurance company, please check 1. If, on the other hand, you think it is extremely important, check 7. If your position is not so strong, then check one of the grades in between. Now, you can see we don't provide labels for the grades in between. Okay, because each participant is left to indicate the grade, to give the grade he or she thinks appropriate. without actually labeling it, apart from the lowest and the highest point. Okay. We don't have any, right? So we have this scale here. So we have 3 scales in the same questionnaire and some other points. This is the satisfaction, the scale that we use to measure satisfaction, and some other loyalty as well that goes after satisfaction and so on. So we can see that we can use in a single questionnaire several scales. And the question that is often asked to me, how long can a questionnaire be? Okay. The answer is as long as should be, so that the data that theory suggests that should be collected is actually collected. Questionnaires that are used in marketing and sales and so on and so forth, or politics maybe, should be short. But questionnaires that are used for academic purposes sometimes might be quite extensive. Another questionnaire that I have here, another scale that I have here to share with you is the Shane's Descriptive Index. This is a proposal for a study. I will leave these documents for you to go through after their meeting, okay? And here we have the Shane's Descriptive Index. This index describes people's characteristics, traits and characteristics, okay? And as you can see, it contains 92 elements, which makes the scale quite extensive. But what can we do? If theory suggests that a person's characteristics can be described in 92 different elements, from being, for example, curious, to be objective, to be shy, firm, prompt, intuitive, frank, I don't know, obedient, decisive, nervous, self-reliant, and so on and so forth. Okay? So we did put together a study that will collect gender and cultural effects on entrepreneurial orientation. And we use the descriptive index, this one that I just shown to you, that was used mainly as regards the managerial qualities of people. But we proposed that we can use the same index for entrepreneurial orientation, okay? Together with culture, to see how, what are the entrepreneurial orientations of people in terms of their culture and their descriptive, the index of their characteristics. And the third example is the actual questionnaire that came out of this proposal after discussing with several partners. Here is the culture again. Okay, totally disagree to totally agree. If your response is not so adamant, check an intermediate mark. And then we have change descriptive index with its 92 items. And finally, we ask participants to assess, to indicate the extent to which they think they are entrepreneurially oriented from 1 to 7. And the idea is try to connect culture, personality characteristics, and try to see whether we can predict the entrepreneurial orientation of people. Okay. There are two issues related to measurement scale. The issue of validity and the issue of reliability. Those of you who followed the research methodologies courses with me or other colleagues, you have already discussed these issues. Let's give a very short reminder of these issues again. The validity is related whether a scale does measure what is made to measure. This is called construct validity. And we very usually use scales to measure different constructs, but do we always measure what we are meant to measure in the first place? How can we measure depression, for example? How can we measure job satisfaction, customer loyalty, national culture, organizational culture, and so on and so forth? There are no observable entities like this. You cannot observe a person to guess his cultural sort of status. This is where the Likert scales come to the equation that allow us to measure constructs like this through measuring a collection of symptoms and or indicators comprising each of the constructs mentioned above. And we have two types of validity: the convergent validity, whether a scale correlates with other scales that are designed to measure the same or similar constructs, and the discriminant validity, on the other hand, or divergent validity, that informs us whether two scales meant not to be highly related are indeed not related. Can we measure validity? The answer is not always. This is why we prefer to use in our studies, you are at the doctor level now. Just let me, yes. Who raised the hand? Just let me look here.
I would like to ask our attendees to drop the questions in the Q&A sections.
Yeah, that would be a good idea.
We cannot speak, unfortunately. So please drop your question in the Q&A. Thank you.
Cannot see what? No, I'm not. All right. You are right, my friend. New share. We need to go back to the. Sorry. Is better now?
We can see the presentation, yes.
Right. So now, okay. Two types of validity, constant validity, different types of validity, constant validity, convergent and divergent. Okay, can we measure validity? The answer is not always. And it is best if we can use in our questionnaires, in our data collection tools, scales that are already in the literature for some time, have been used in the past, and their use is validated through, for example, submitting papers using these scales for publication in journals have gone through the double blind review process and so on. On the other hand, we have the content validity, which tells us whether a scale is representative of all aspects of the construct. And the phase validity, how suitable the content of a scale seems to be. Phase validity is subjective, okay? Hence, it's the weakest of all types of validity. If aspects are missing or irrelevant aspects are included, validity is threatened. Which means what? We can only use ready-made scales from the literature? The answer is no. But we can use these scales as the framework that we discuss with our partners or with the people that we trust their knowledge on the subject, and with the purpose to either add or remove or change items from the original scale so that it better fits the situation that we are now facing. Another type of validity is the criterion validity. Criterion validity is something that we can measure. For example, theory says that ServQual can measure customer satisfaction, can be used to ServQual affects customer satisfaction. You can see in the questionnaire that I have shown you earlier, we had the ServQual scale, and then we had the customer satisfaction scale. Theory says that ServQual can actually affect customer satisfaction, and in fact, it goes further to also affect customer loyalty. Okay, so we can use, for example, in the correlation between constructs, between the dimensions of service quality to customer satisfaction, or actually conduct a regression analysis to see how the scale can predict the criterion measurement. In the study that I talked to you about earlier, actually we picked the ServQual scale, which consists of 22 items, and we added 4 additional items so that our scale better fitted the Greek insurance landscape of the time, something like 10 years ago. Okay, so we used this criterion validity path to measure the validity of our scale through conducting regression analysis to see how our scale could predict the customer satisfaction of participants. And we have two types of criterion validity: the concurrent validity, where both scale scores and criterion scores are taken at the same time, or the predicted validity, which means that scale scores are measured before the criterion scores. Okay, so more or less, apart from the criterion validity, other types of validity actually depend on whether the scales we use have been already used in the literature and are part of the theory on which our studies will rest. Okay, Rebecca says, you mentioned that the questionnaire for academics should be extensive. Please elaborate whether, okay. Okay, and Noor Ikiran asks, please give your preference for using Liberty scale it's not Likert scale, it's not Liberty scale. It's Likert scale, all right? Of 7 or odd, no odd number, okay? No odd number, because no even number of points, all right? Always odd number of points. When I was in your shoes, a doctoral candidate, I thought that the 7-point scale might be more, detailed, all right? But since then, I've seen several thousands of such studies, all using the 5-point scale. So nowadays, the 5-point scale is considered appropriate, okay? Even number of scale, of course. No, if you have an even number of scale, is the only way that you include neutrality in your measurement. Because you have a 5-point scale, 3 is neither nor, okay? Not important, and at the same time not unimportant. Okay, if you have an even point scale, then you will have the so-called forced distribution, because you will have which is going to be the middle point, neither nor, 2 or 4, okay? Sorry, 2 or 3. 2 is too low, 3 is too high. So this is why we always have even odd point scales. Rebecca says that I mentioned that the questionnaire for academics should be extensive. No, actually, Rebecca, I did not mention this. I did not mention that they should be extensive. I just mentioned that sometimes need to be extensive so that the data that theory expects from us to collect is collected. Okay? So I don't have an answer to give you on how lengthy or short a questionnaire needs to be, as long as it takes. Hi, Lucian. How do I calculate the validity from my data? Okay, using SPSS. Okay, I think I just, Suleiman, I just got you the answer. You can use correlation or a regression analysis so that you can calculate the validity. Although calculating validity is not an issue in most cases. Any odd number, Catherine, but most people use 5 or 7. In fact, 5. All right. No, we don't measure all types of validity. All content validity is actually the most important. This we cannot always measure. And all right. That's an interesting question. Okay. What happens when most respondents select the middle points of the Likert scale? So you have done something wrong, because if they do so, then your list of questions might not be correct. Okay. Then your numbers. Okay. Let's go on then. Let's proceed to the reliability of a scale. Reliability that can be measured. Reliability is the extent to which a scale produces consistent results when applied in different circumstances or within the same study or different studies. By different circumstances, we mean different times, by different researchers, and in different cases, in different countries. All right. So we have the scale, a culture scale, Hofstadter scale, or a circle scale, or the Shames descriptive index scales that are used quite a lot throughout the globe. And we say that they are reliable if they produce consistent results. And we can measure reliability, actually. We have 2 types of reliability: the test-retest assessment, in which we apply the scale at 2 different distances, sometime apart from each other, or different samples out of our population, or samples of our own sample, and compute the intra-class correlation coefficient between the scores. Okay, we'll have an example now. All right, let's have an example now. Give me a moment. What we have here, what we have here, can you see it, please? Okay. Mohammed, no, structure equation modeling is not just about measuring quality or satisfaction. We first measure quality and or satisfaction, okay? And then we use these concepts in also using another software, which is about conducting structural equation modeling analysis. Okay, so if you can see that here, Olga, can it be seen? What we have here, we had a study that we described earlier about looking into the entrepreneurial personality traits of students. And we have a sample, an overall sample of, I don't know, 450 people. Some of them were men, some of them were women, some were managers, some other were not managers. So we had managers in general. We have men managers, women managers, and people who were not managers and so on. And we would want to see the scale that we used, whether it was reliable and to what extent. We so went to the analyze scale reliability analysis. Okay. Can you see this? We took all these items here and send them to the items box. The items to be analyzed. And then we click the statistics button here. And clicked into the intra-class correlation coefficient. We checked for consistency or absolute agreement. In this case, we would have identical results. Let's choose absolute agreement. Okay. Let me now. And this is the output of the analysis. The intra-class correlation is quite high, okay? No matter whether we used average measures or single measures, quite high, which means that the test-retest reliability of the scale is quite high. We could, for example, restrict our analysis, for example, between managers men and managers women. So remove all other variables here. You can see that the intra-class correlation is rather higher. The single measures one raises from 0.915 to 0.984, and the average measures one rises from 0.985 to 0.992. Okay. So this is how the test-retest reliability is assessed. But in most cases, we would use the internal consistency analysis. That refers to the extent that all items of a scale are measuring the same underlying structure, and the most commonly used indicator for this internal consistency is Grombach's alpha. Grombach's alpha. Grombach was the mathematician who actually introduced this statistic, and alpha is out of the Greek alpha, which equals A, okay? Alpha values greater than 0.7 indicate good internal consistency. However, the alpha values of a scale depend on the number of items. The more items we have in a scale, the higher the alpha value that we expect is. When we have very short scale, the alpha values are lower. But in any case, we need them to be greater than 0.7. Okay. This we have discussed already. Let's go to the proper, as I call it, reliability analysis. Let's open another SPSS file. Let me find it, please, for you. You share this one. We have data from a study, a description of the questionnaire here, several scales, this comes from Scheller, Carver, and Bridges in 1994, describing different feelings, anxiety, okay? Another scale from Watson, Clark, and Tellegen, describing different feelings, okay? And we will use this scale for our example. Okay, we'll use this scale. Items PN1 to PN20, analyze. Dimension reduction. We now go to, we are still in the reliability scale, reliability analysis, sorry. Items PN1 to PN22, 20. Okay. We put them into the box, the items box. We go to statistics. Item scale if item deleted. We click to the descriptive box or all items here. Just give me a moment, please. No, nothing else here. Okay. This is the Grompa alpha. We have 20 items. The alpha value is 0.736, but let me come to this. You can see these items. Okay. I have several questions here. I will answer, I will come to you in a moment, all right? Okay, so here we have a 20 item scale. As you can see, we had 100 items to 43 items, of which 4 were excluded because answers were not complete. Participants did not answer to all the questions, okay? So 439 participants' complete answers remained, on which we base our analysis. The Grompa alpha is 0.736, which is above the threshold of 0.7, sorry, okay? Which in technical terms is acceptable. What is very important and very interesting is this table here, the item total statistics. Okay, and especially this very last column here, which tells us that if an item is deleted, what will happen to the alpha value. As you can see, we have our overall alpha value is 0.736, okay? In certain cases, we will see that if an item or more than one item is deleted, the alpha value will increase, okay? Which calls us to decide whether we are prepared to sacrifice a piece of information, because in each of these items is providing us a piece of information. Okay, so are we prepared to sacrifice information so that we increase the alpha value? This is a question that it's up to you to decide upon. If I
Dr. Tsoukatos,
yeah,
is
yes.
it possible to enlarge a little bit the
yeah,
prints?
I don't
Yes,
know.
we cannot see the
Give
big.
me a moment. I'm not sure that can be done.
I don't see also, but they requested if possible. If not, we proceed.
Just a moment. Yes, I will try to. Okay, we've seen this. No, that's another one. Just give me a moment. I will move. Is this better? Is this better, Olga? Is this better? No one. This is the analysis that you couldn't see. Here is the alpha value. Okay. Technically is above the 0.7 threshold, but not so good for a scale with 20 items. Actually, we expect a higher alpha values in scales with as much as 20 or more items. And this is the table that we've seen earlier, the Grompa alpha if item deleted. If you have numbers here that exceed the 0.7, the alpha value previously indicated, then what you need to do is remove these items and rerun the analysis until no further improvement is possible. Okay, let's see what kind of questions we have. Great. You use data depth, all right? Great. This is some other type of software. I read somewhere that if the Cronbach alpha is 0.97, then the data is questionable. It should be between 0.8 to 0.94 to be reliable. I don't think so. Okay. 0.97 is a very high reliability. Unless you have any evidence that data is somehow, manipulated, then why not accepting it? Yes, I know you meant question. All right. No, I don't think so. Okay. Are we okay? Any other questions, please? Mohammed, structural equation modeling is not about measuring quality or satisfaction, unless what we need to do is confirmatory factor analysis, for which we will talk in a few moments. How blessings will come. Yes, we can see them. Yes, you will have the recordings, right? Of course. All right. This is all about reliability and validity of scales. The next hour of our meeting will be devoted to exploratory factor analysis. Okay? So I will remove this presentation. Actually, remove everything that we don't need. And we'll come to the our next presentation, which is the exploratory factor analysis presentation. Factor analysis, okay? The next step. If we have a scale, the first thing we do is assessing the scale reliability, validity first, and then reliability. And once we are satisfied that the scale that we're using is valid and reliable, then the next step is to factor analyze it, as we call it. Which means what? Which is about summarizing the set of manifest variables, of the items of a scale. Okay, we have a scale with a large set of items, otherwise manifest variables. Okay, each of these items is a variable. Okay, that is measured across a number of several hundred of participants or several thousand of participants. Okay? But you see, we had in our examples up to 92 such items. Okay? And we need to reduce into a smaller set of factors or components, otherwise latent variables, variables that cannot be measured as manifest variables can be. Okay. So we start with a large number of items and reduce this to a smaller number of logical groups, actually. Those latent variables are nothing else but logical groups, so-called factors. And we have exploratory factor analysis, which is conducted through using software like SPSS or Stata or other. I'm not sure that the R software also can conduct just give me a moment, please. Stafford asks, do we adjust the number to get a good reliability, or do we use the data set from the questionnaire to, yes, we use the data set from the questionnaire. Otherwise, would be data manipulation, which is unethical. We can't do that. We do not manipulate data just to present a good thesis or dissertation. Okay? No, we never manipulate data. We use the data we have just to check if they are appropriate. If not, then maybe we should do something to either collect more data or revise our questions so that the data we collect is appropriate. Of course, we do not manipulate data. Okay. We have two types of factor analysis: the exploratory factor analysis, where we develop the scale, and there are no a priori hypotheses about the factors of the scale. Between us, we also use it when there are a priori hypotheses, just to check whether our own data is compatible with the data collected in previous studies. And if it is in line, if our data is in line with data presented previously, then we can be quite sure that our scale is on the right direction. Okay, but technically and theoretically, if we have a priori hypothesis about how the scale should be, then we use confirmatory factor analysis, which is part of the structural equations modeling technique. And we cannot use SPSS for confirmatory factor analysis. There is other software for this, like IBM Amos, PLS, Lizrel, and so on. Okay, so here is, let's see, we had a scale with 6 items that were divided into 2 factors. Okay. So the assumptions for using factor analysis. We have interval data or ordinal data. Actually, Likert scales are introduced so that they provide us with ordinal data. There are no outliers among cases. We can use our software to check for this and remove outliers. Variables, the items actually, are linearly related to each other. SPSS can do this check for us. But on the other hand, they are not heavily correlated because this will lead us to a problematic situation. To be honest, the factor analysis, exploratory factor analysis, is so robust that we do not always check whether all these assumptions are met. But if you use the method as part of your dissertation or your thesis, please do so. Please check for all these assumptions because you will be asked during your viva. When do we have adequate data, enough data? No consensus, just a rule of thumb. 10 observations per variable in most cases. Okay? If you have a small sample, then what can you do? For example, imagine that we have the 92 items index, Shane's index, and you have only 250 data items, participants. Do we have enough data for factor analysis or not? The rule of thumb is 10 observations per item, which means almost 100 properly filled questionnaires. But is it the case always? No, it is not. We'll have a chance to discuss about it in a few minutes. We need the variables to be moderately correlated, which means that we need to see in the correlation matrix that will be produced some correlations, at least some correlations above the 0.3, and the Bartlett's test of sphericity is significant. We'll see what this test is. And the Kaiser-Meyer-Olkin measure of sampling adequacy is above 0.6. Okay? So if all these are met, requirements are met, then we have an adequate data set of adequate size for our analysis. If not all are met, then again we can we can have an adequate data sample, but provided that some prerequisites exist. That we will discuss later on. Let's have an example. the same data set that we used earlier, the PN1 to PN2 sorry. Or maybe we should use a more recent data set that we produced with one of my very recent PhD students. Sorry, just give me a moment, please. This is the data set. Data set that gives us, informs us how the so-called XYZ framework can help young people towards improving their position in society. Contributing to their income, to becoming more confident in addressing issues that concern them, achieving goals, okay, so improving their lives. And we have items 2 to 22 here, describing how this can be done, how these young people in a developing country can be helped to improve their lives. Here is our data set. Let's see a little bit to the variables. These are our variables here. Our variables here. We have altogether, we have 28 items in our questionnaire. Items 2 to 22 are trying to describe how the XYZ framework can help people to improve themselves. And then items 23 to 28 describe how useful the XYZ framework is considered, is perceived. First, what the XYZ can do for people, and based on this, how people perceive the usefulness of XYZ framework. Okay, let's go on to it. New share, here we are, share. We have used Likert scales. Items, for example, if we come here, this is the description of the Likert scale. 1 is strongly disagree, 2 disagree, 3 neutral, 4 agree, 5 strongly agree. New share again. I know it's quite screen sharing, all right. Okay, if we don't want to see all these strongly agree, neutral agree, and so on and so forth, we can go from view and unclick the value labels, all right? And here are the original numbers that were used and named one as strongly disagree and so on. We don't need the labels for the analysis. So let's see. Analyze, dimension reduction, factor, items 2 to 22. We send them to the VOC, to the variables box. Factor analysis is about two things, actually. It's about producing an original solution. Consider that we have an object having 22 dimensions. Actually, the human being can visualize objects having 3 dimensions, all right? Actually, Einstein introduced a 4th dimension, which is time. But we cannot visualize items like having 22 dimensions like this, 21, sorry, or even more, okay? So we need to reduce the dimensions into something that we can actually visualize and work with. The first step of the process is to produce the initial solution, so-called. So we go to extraction. We want the correlation matrix. We need the scree plot. We will see what this scree plot is. And for the initial solution, we will use the principal component analysis method. There are quite a number of methods here, okay? But, or the maximum likelihood or whatever. We first start our analysis with the principal components analysis method. Continue. So we will have our first solution here. And then once we have this first solution, we rotate the item so that we come to the best solution, and this is done through the Varimax rotation method. The Varimax rotation method. Continue. Some descriptive statistics that we will need will be the KMO and battle test of sphericity, of course, okay? Just to see how good are in terms of data. Then we will go to the scores. No, nothing here. We go to the options, click to the suppress small coefficients. Theory says that coefficients below the level of 50.55 are non-significant, and we'll see what, in a moment, we'll see what these values are. And completing this, then we are ready to press OK and have the analysis. New share. The analysis here. Let me see how I can increase. Here it is. Oh. Zoom out. Zoom in. No. Zoom in. Next page. Oh, sorry, it's not close. Can you see that?
Yes, we can see.
Good enough, Olga?
On my screen, yes. I'm not sure if
Right. Okay, first question. Do we have enough data? We can see to the KMO and Battles test. The KMO test is 0.965, which is very close to 1, quite a long way from 0.6, which is the minimum, okay? And the sphericity test is significant at the 0.000 level, which is quite below the 0.05 level, is 0.005 level, which is the acceptable threshold, which means that in terms of these two tests, we have enough data for the analysis. The second thing that we need to, the second table that we need to see, sorry, I didn't ask for it, sorry. Analyze scale, reliability, no dimension, that factor. Just give me a moment, yes. Descriptives. Extraction. Correlation matrix. Scores. Sorry, I can't find it now. Okay, so the factor analysis. Okay, this is the factors that were produced out of the analysis. The 22 items were reduced into two factors that explain 62% of the variance, which is a good percentage. In real term data is quite good percentage. This is the two factors that were produced. We'll see what the factors will be. Okay? And then we have a script plot here. Consider that you have a straight line starting from here, something like that, from point, say 4 to point 21. But you will see 1, 2, 3 nodes like this on the same side of the line, on the upper side of the line, which maybe indicates that the script plot suggests that there are no only 2 factors in the analysis, but there might be 3 of them. Okay? Oops. That's an issue. And my student and I went back to theory to see what does theory suggest on this specific scale. And theory actually suggested that there are 3 factors. And how come we came with only 2 factors? Because maybe different circumstances, COVID situation, certain political or certain social issues changed the situation a little bit. Or maybe our sample was not representative enough. And then we went back to our analysis to ask for as many factors as theory suggests here. We need 3 factors. We do not let SPSS or the analysis, factor analysis, to produce the factors the analysis seems appropriate, but we decided to comply by theory and go for 3 factors. These numbers are the same. Oh yes, we have 3 factors now. Actually, our 3 factors explain 66% of the variance, which is even higher than the 62% we had previously. So we decided to go with this analysis. And the final matrix that we had here is this one. 3-factor analysis. As you can see, this one, item 2, 3, 4, 5, 6, 7, and 8 are excluded from the analysis. So no, 6, 7. 2, 3, 4, 5, 6. Item 7 is excluded from the analysis because the loading factor, these are called the loading factors, was below the threshold of 0.55 that we set previously, that loadings below this point should be excluded. We also have this one here excluded from the analysis. And this is it. we have 3 factors altogether, 1, 2, 3. Factor number 1, the most important, that explains 27% of the variance. Factor 2, that explains 19%, and factor 3, that explains another 19% or so. Okay? Now, the question is now, okay, enough with statistics, enough with SPSS, enough with the analysis. Now we need to give a name to those factors. Just a moment, I have a question from Ande. Sir, you just mentioned in the case we had Grompach alpha value as 0.736, that is not too good, okay. Does it mean that the greater the items, exactly. The more the items, the greater the Grompach alpha value is expected to be, okay? Is expected to be. Can this kind of analysis be conducted? No. Anthony, no. MS Excel does not conduct this type of analysis. Can I please clarify? Okay, we will come back Ansia later, all right? First, I do phase validity, content validity, then I do a pilot study from my pilot studies where I calculate my cost. All right. First, I do phase validity, content validity. All right, phase validity comes first, which is subjective, okay, seems to be okay. Then we have to analyze and discuss the scale with theory. And our colleagues and with people, okay, in a sort of pilot study framework, okay, to discuss it with people, to see the literature, discuss it with people who we trust their opinion, and come up with a scale that it's valid to the best of our knowledge, okay? And then we go on to the reliability, okay? Yes, of course. Yes, okay. In general, when the objective of our study is to measure relations between variables, like in factor analysis, like in structural equations modeling, and so on, okay? Having probability samples is not so crucial as a requirement. These methods can very well work with non-probability samples, like, for example, convenience samples. And in fact, in most cases, it is convenience samples that we have. Because for probability samples to be even possible, we need to have the sampling frames, which means the complete list of the population in question, which is quite rarely the case. Okay. All right. So yes, Doc, I also need clarity on the rotated component matrix, Varimax. Is it the same as factor load? No. Factor loadings, Varimax rotation is a method of rotating the initial solution. Factor loadings are these numbers here. 0.671, 0.678, okay? The higher the loadings, the better is the solution. Okay. So factor loading is different. We're going to make sure, validity, all right. When is the pilot test data? The reliability test is performed on the entire data, all right?
Yes, Dr. Tsoukatos, if possible, to read the questions aloud as we are recording, and it will not be available for those who are.
But I read them. Okay. When is the reliability test performed? Pilot test data or the entire data? And the answer is the entire data, okay? First, I do phase validity. Ansi asks, first I do phase validity, content validity. Then I do a pilot study from my pilot studies where I calculate my construct validity and reliability, which is the Grompak alpha. Okay, first we have phase validity, okay? What it seems, what the scale seems to be like, all right? Then we go to the literature, to theory, to see if all elements that were supposed to be in the scale are there. Then we can do, or at the same time, we can do a pilot study with very few people that the opinions of who we trust, to discuss whether we need to revise some questions or some statements, or add some statements, or remove some items, and so on, because they do not fit to the cultural environment where the questionnaire is going to be applied, for example, okay? And considering all this, theory, the pilot study, and the discussion with experts or knowledge people, then we come up with a scale that is valid to the best of our knowledge, okay? Once we collect the data, okay, then we can calculate the validity. We can, for example, use, as we will do here, okay, we'll use, we have used the factors that we produced here to calculate, to see their effects on the second part of the scale, which is our perceptions of the usefulness of the framework. Okay, right. Now we have these three factors here, and then comes our imagination, enough with statistics for the time being. Factor one, let's read the statements. I have improved my digital skills through courses that cover topics on digital competencies. I learned at least one important life skill. Because of XYZ, I encourage others to help improve my community. I have become more involved in the community. Because of XYZ, I developed the capability to help address natural shocks, such as COVID and so on. Okay? Help me to identify possible career options, and so on. So it's up to you, it's up to each researcher to give a name that makes sense to each of these factors. For the time being, we will call them factor 1, factor 2, and factor 3. Okay. So this is a very short introduction of factor analysis. I would suggest that you find in online a book that can be downloaded for free, previous versions of it, SPSS Survival Manual by Pallant. SPSS Survival Manual by Pallant. Let me see if I can find it for you. Yes, you can find it. The 6th edition is can be downloaded for free from the internet. The 7th edition you have to buy, but previous editions you can. Okay, SPSS Survival Manual. You can download it for free from the internet. All right. Okay.
Thank you very much, Dr. Tsoukatos. We are continuing with the
Yes,
webinar.
we are.
We have another 13 minutes.
Okay, yes, I know. Took us more time than I thought. Okay. Now, the next thing we can do now, let's see. Let's do the factor analysis of the second scale in our questionnaire. Analyze, again, dimension reduction. Now we are going to remove the 21 items that we already analyzed and send to the variables box the remaining 6 items. But theory, we do not need to have 3 factors here, so we leave SPSS to choose how many factors will be produced. Our criteria, very good. We have enough data. And actually, as we expected, we have just one factor. Okay. Here is a script plot also corroborating this, and this is the factor we have. All right, so what else can we do at this point? One thing we can do, the best thing we can do, the most acceptable thing, since you are at the doctorate level, is to put these latent variables we produced here, the 3 factors from the first scale and the 1 factor from the second scale, and use these latent variables in using either the PLS software or the IBM Amos software to conduct structural equations modeling analysis. But if you want to produce variables out of the factors, okay, you still can, as follows. For example, let's see, we have factor 1. We have items. Factor 1 is items 9, 10, 12, 13, 14, 15, 16, 9, 10, 12. So the second factor is item 2, 20, 2, 19, 20, 21, 22. And the third factor is items 3, 4, 5, 6, 7. 3, 4, 5, 6, 4, 5, 6, 7. Okay? So we can produce a variable out of each factor. Transform. Compute variable. We give a name, factor 1. The mean value of items. This is what? 9. Okay. 10. 12. 13. 14. 15. 16. 17. And 9 and 18. Close the parenthesis. Okay. And we have a new variable. A new variable that can be seen here. This is it. Factor 1. This is the new variable. Okay, let's do the same for the other 2 factors. Transform, compute variable, this time factor 2, and the variables are variable 2, 19, which is 19, which is 19. Just give me a moment, please. 19, 20, 21, and 22. Here is our second variable. And our third variable, compute variables, is 3 to 3 3, 4, 5, 6, and 7. Okay. So we have our three variables. Let's make another variable, the perception variable, the remaining items. Usefulness. For example, the items are (23, 24, 25, 26, 27, 28). Okay. Okay. Consider now that we want to see whether factors 1, factors 2, the factors 1, 2, and 3, okay, can predict usefulness. How can we do that? The best way to do so just a moment. We will use, for example, multiple regression analysis. Linear, we can use. The dependent variable would be the usefulness, and the independent variables would be factors 1, 2, and 3. Okay. Look what happens here. What just happened here. This is the analysis, okay? The R-square coefficient, 0.556, which means that the three independent variables can explain 55.6% of the variance that is observed in the dependent variable, okay? And you have factors 1, 2, and 3, which means, and we look here at the significance column at the end, which is 0, 0, 0, 0.000, 0.000, 0.001, okay? Which mean that all these factors actually affect the perception of usefulness, okay? Positively, the coefficient in each variable is 0.296, 0.274, 0.2165, and so on. And this is a very good computational validity, okay? Predictive validity. But for a more complete analysis of this data, we should go on to structural equations modeling, work with latent variables, and some other colleague will discuss this with you whenever Dr. Olga will tell us. Okay, let's see some questions. Hi, Olga. Just give me a few minutes for. There is one interesting question. Given that the reliability is measured on all data and not on at the piloting stage, what happens if Grompax alpha is less than 0.7 when the data collection process has been completed? That's a very good question, which means that something is wrong and that we need to be very, 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 I don't know how many varies can I say, to be very careful when conducting our sampling and when we are constructing our questionnaires. Okay? Exactly. This is a sign that something is wrong. All right? After piloting, how can you do that? Piloting is with 10 or 15 people. Okay? So you have only 10 or 15 participants. There's no use in such studies. If you need at least 10 observations per item. So these things should be very carefully designed in advance. Okay, that's enough from me, Olga, and ladies and gentlemen.
Yes, thank you. We would like to thank you, Dr. Tsoukatos, for starting this series of statistics webinars. And we are going to share later on the full list of webinars that we are going to offer.
Right.
I think that we will start next year. I would like to thank you for initiating this, starting with this webinar. I would like to remind everyone that the session was recorded and it will be shared on the Student Help Center, so you can use it at your own convenience and watch it again and again and again. And
do not hesitate to ask should you need more information on it.
Yes, probably we may arrange with Dr. Tsoukatos another webinar just for questions and answer session, probably if we arrange it in near future. It's going to be next year for sure. And I would like to thank our Dr. Tsoukatos for participating in preparing this webinar for us.
And you were very lucky because you have Olga here, organizes everything. And you were very lucky because when I was in your shoes, I had to learn all this by myself.
Yes, yes, many students were asking for these webinars for quite a long time, and we are happy to start implementing this and offering this. We had many questions in Q&A sections. Many thanks to you, Dr. Tsoukatos, for providing this webinar. I know that many students also passed with you the research methods stage. So not webinar, the module.
All right.
Yes, so let's hope that it will be useful for you. You can find it at any convenience on the Help Center and use it and for your future research as well. Dr. Tsoukatos, thank you very much for participating and presenting to us. Thank you very much to all attendees for coming up with many questions today, and stay tuned. You will receive more invitations to other events in the near future.
Okay, thank you for being all together. Have a Merry Christmas and a very Happy New Year.
Same to you. Dr. Tsoukatos, would you like to come?
Yeah. Let's
I will send you the
remain.
link, okay?
Sorry?
I will send you the link now to the meeting.
Right, okay.
Thank you.
Right.
Bye-bye.
Bye-bye.